in 5 years, 50% of businesses are failing. And in terms of startups, it's probably 80% in 2 years or something like that. So it's crazy number, actually.
You don't need to force them and rewrite your entire project to use abstract factory method or something.
It's always about identifying some problem that is really a problem and not solving some imaginary problems.
Yeah, this is exactly the idea of having one great system that you just add tiny pieces to. And of course, it makes sense for a bigger company, but sometimes you can go too far. Hello, I am Miłosz.
And I'm Robert. And this is No Silver Bullet podcast, where we discuss mindful backend engineering. In this show, we share takes on software engineering that will help you to grow into principal engineer level.
Let's talk about the usual arc of a software project. So first we have the kickoff, and now we have high hopes of good design, and this product will be great, and everything is fine.
This time we'll do it right.
Yeah. And then we work on it for some time, then we deploy it to production, everything is great, and suddenly it becomes a legacy project no one wants to touch. Did you ever see this happen?
Every time. Okay, not every time, but yeah, it's very often the case.
So it's interesting, right? Why does it happen? Why every project ends up as this, or maybe almost any project ends up as this big ball of mud no one wants to work with? I guess that very often the first version works quite well. We come up with something, it's pretty much what we wanted, that's fine. And then new features come in, and very often they are quite different than what the software did in the first place, right? So we need to change the design. But very often there is not enough time, or developers are lazy, or they don't feel like it, whatever, but they don't remodel everything to fit the new design. Instead, we add some workarounds or hacks, and it works pretty well for a while, except it adds maybe some bugs, maybe some unusual behaviors, and we repeat it over and over months or years. And yeah, and then we arrive at the state that we are afraid to touch the code base. Is there a way to fix it?
Well, it wouldn't be surprising to say that it's a problem that software always had. So probably there are some magic techniques that are trying to solve this problem. One of the most popular, let's say, tools or techniques that are trying to approach that is domain-driven design. But if you heard about domain-driven design, probably also noticed that for some reason it's not the default way of many teams to work. So from one side, we have some solution. From other side, probably it didn't solve all the issues that we have.
Yeah, and it's also sometimes confusing. Sometimes it seems like something you would use only for enterprise projects. But actually, it worked for us before. So we like talking about it and sharing the ideas.
And look how people are surprised sometimes to hear that it worked for us, because many people try to use domain-driven design and it introduced more mess for them. Or maybe they worked in a project when somebody tried to use domain-driven design and it's the worst experience that they have. Interesting.
So the bold assumptions for today's episode is that you can go deep into many DDD ideas, and they shine in complex projects, but very often you can use some more basic version of the key ideas of it and apply it to most projects, actually.
So, in other words, in this episode, we will cover how to not use domain-driven design, but some part of domain-driven design, and how to make them useful in your projects.
First, let's think about what is difficult about building software. So let's consider someone wants to start and they want to learn some programming language, right? What would you recommend them to learn?
Maybe not what I would recommend, but what people are
usually... Maybe also default answer here. So they probably need some programming language, right?
Yeah, Kubernetes,
yeah,
OP design patterns.
Maybe learn some framework, some good practices, some algorithms, maybe data structures, stuff like that.
useful stuff that you are using on interviews, in other words.
Exactly. So,
And it's actually, I think, pretty interesting that a lot of learnings that nowadays is focused around things that are useful for interviews, but from other side, they are not that relevant when you are working a job. And I would say that it's even worse because you are solving problems that normally you should not solve in the problems that you are working. Like, you should probably not implement your own databases and you implement binary trees because Postgres have that out of the box.
yeah, but at the same time, if this person who wants to join a company, they probably need to learn some computer science theory, like what is big O notation, how to write optimized algorithms for sorting, how to create data structures, stuff like that.
And it's useful.
Yeah, it is. And it's often what you need to know to join a company. But my question is it enough to ship good software?
Well, I would say that it's not enough and probably it's even not needed. So, because, well, we are people who are self-taught. So we've been learning programming ourselves and we've been shipping multiple projects without that, basically. And many people were using that. They were maybe not perfect, but from the other side, they worked.
Yeah. So I would say it's like half of the skills you need. And it's useful, it's needed. It's often what we focus on. But there's also the other half of stuff you need to ship good software. So what we discussed so far is the technical complexity, right? So making software fast and scalable and optimizing memory usage and stuff like this.
Probably we can put it to bucket of software engineering. So this is this hard part, maybe not hard, but this
low level part, maybe.
Yeah,
the coding part. And the other half, how would you call it?
So if you are working with product, probably product engineering.
Yeah, so the product or domain challenges, right? So basically figuring out how the thing should work and what should it do.
Yeah, so this product engineering or those domain challenges, it's less about those technical part, but rather thinking how to tackle complexity, how this feature should work. Maybe, even thinking if it will be useful, because if you know if something is not useful, you can remove some functionality and decrease complexity with that. It's also this less priced part, let's say, that it's connected to communicating to people.
Figuring out together what you want to build. Maybe also talking to your users.
I think it's also part related to some long-term maintenance. So it's, I would say, it's partially part of the software engineering, but I think it's often lost somewhere because when you have software that is not that maintainable, from other side, it's also challenging. And I would say that a lot of people that have this engineering mindset, they like challenges. So if software is complicated, it's great because we have a lot of challenges there to solve.
Yeah, the technical parts are very interesting to solve. We like puzzles, right? At least I know I like them too. And the technical parts often have a very specific answer to them. For example, we can have an SQL query, you can benchmark it, and then you can come up with a faster query. And it's very easy to compare if it takes 2 seconds or 10 milliseconds. And it feels great to have this measurable progress. But for many businesses, it's not really critical at all. If your website handles a request in 50 or 70 milliseconds or whatever, it's usually not a huge difference, maybe except for the first page load, which is critical. But for many web applications, if saving some data takes 1 second longer or shorter, it's not a huge deal and probably not worth spending days on coding on.
As long as cost is not the important part, but again, it's also some subset of products. For many products, it's not that important at the end.
Exactly. But for most businesses, the hard part is taking the problem domain they need to solve and representing this in code, especially if the problem domain itself is complex. And usually the real world is messy in itself, right? So we have no easy way to compare if something works or not, like with the technical parts.
Mm-hmm.
We often need to experiment, see if something sticks, see how users use it.
So basically the feedback loop is much longer, and it's not that obvious. Like you said with SQL query, it's easy to measure if SQL query is faster or not, but obviously you can measure some customer satisfaction or some feature, but it's more indirect and it's usually taking a bit longer to get back to you. And it's also a bit harder to understand sometimes how it's happening, because you can change some functionality and notice that, okay, some behavior changed, but sometimes you may have that many changes around that it's hard to judge if it's because of it, actually.
Yeah, so it's much more vague. And if you consider most of applications, like SaaS apps, they are usually very similar. Like if you change jobs, right, and let's say you used to work on web application using Go and TypeScript, you can end up at another completely different company and use the same tech stack.
Mm-hmm.
It's not much different. You use the same programming language, maybe even the same framework. Basically, protocols, databases are very similar. They don't change much. But on the other hand, what the company does can be completely different. And this is the differentiating factor between them. It's sometimes funny how companies try to make the technical choices something that makes them distinct. So I don't know if you remember, about 10 years ago, there was this hype on MongoDB, for example.
Oh, yeah.
and some companies were very open about it.
I'm proud. So when you've been sending CV and it was the job posting, it was, yeah, we are using MongoDB.
Yeah, we are web scale. But of course, it did not really matter in the end. Like
it's so absurd. But it's also interesting because during that time, some people were saying that it's absurd, but from other sides, many people were following that and saying, yeah, it's so great, you're using MongoDB, your web scale. So let's see what we'll see 10 years from now.
You could just as well use a JSON column in Postgres, right? Achieve pretty much the same thing, except for some differences in very specific cases.
Or losing changes because of inconsistencies between nodes.
Yeah, but basically, if you take two companies that do the same thing, and one uses that database and the other MongoDB, whatever, it probably won't impact that much the end result. How well they do in business, how many users they have, how good the product is. There's a lot more factors in it.
Okay. So in other words, we can say that many companies, many people maybe solve on the wrong thing, because when starting a new project, they're thinking, okay, this time we'll use this framework, this database.
Yeah, it will be different this time.
Yeah. And this time everything will be great. And again, we are in this cycle of starting in the greenfield and ending up with legacy, like it was done 5 years ago, 10 years ago. So probably the technology that we're using, the framework database, maybe not the most important indicator if project is successful or not. And by successful, I mean multiple things. So if it's maintainable, if it has user, if it makes money, probably from perspective of developers, the maintenance is the most important part, but again, it's not the only thing.
Yeah, but we treat it as something that's the core thing we need to solve sometimes, right? Like I remember some companies that were very with the idea that we will dedicate top talent to this core platform framework something, and once we solve it, then adding new features and apps to it will be trivial. We'll just hire anyone who's able to code in this language, and they will just use this great framework to implement a new feature in one day. And that's, I don't know where this idea comes from, but I think it's quite common.
And I think one part of the problem may be that if you are hiring specialists in many fields, the sentence that if you have hammer in your hand, you see nails everywhere may happen. I mean, if you hire specialists from multiple areas, they will spend a ton of time on solving problems that maybe not the problem in this company yet. So for example, if it's a startup and it's starting, they don't have scale yet, and probably it could be run on a single VM. And later you have, for example, some Kubernetes specialists. So
boring.
What they can do, they can create multiple Kubernetes clusters for multiple environments and later serve 1 request per second and even 10 requests per second. It's like nothing. You can do it with a single VM, but it's not for free. But yeah, obviously you're using your top talents, but for solving problems that are not important.
And I remember myself falling into this trap, probably multiple times. But one story that I remember very well is how I used to run some game jams with friends, just making game in 2 days, right? And one time we wanted to create a story-driven game with a lot of dialogues. So you can choose dialogue options and it leads you to a different part of the game. And somehow we came up that we will do it event-driven. So each option will be an event that sends and triggers something. And we had this idea that, this will be a lot of events, so it will be hard to manage. So we will need this event-driven framework. So if only we get this framework right, all that's left is to implement the dialogues, and that's it. That will be it. So we spent many hours creating this messaging framework using generics. And it was in C#, which I didn't know very well. So it was super fun to come up with it. And in the end, we had this great interface that, you can very easily publish an event and very easily subscribe to it. And the result was that it was probably the only game jam we never finished. Because we had this technical solution, but we didn't progress with the game at all.
So in other words, you are not the best specialist to be hired to build event-driven games.
Exactly. I can create a framework for you.
But yeah, I think it shows...
It's like a very condensed, scenario that I think happens on bigger scale as well. And I don't even know where it comes from, but somehow we tend to think if only we can create this, this framework first, then everything will be easy.
And sometimes if you succeed to create this framework or whatever it is, this prerequisite, and you're starting to really work on the things that matter, you're starting to notice that, okay, actually it's totally not needed. We just spent 2 months on that, and you know what's the worst thing? The worst thing about that is sunk cost fallacy. So you're spending more and more time on maintaining that, losing a lot of resources, time, and nerves on maintaining that when it's no longer needed. So
yeah, and you don't want to get rid of it because you invested so much time. Yeah, I think we've seen many examples like that, right? I think it's very common when you have like a platform team in a company that is supposed to make all teams work together in a very similar way. This is exactly the idea of having one great system that you just add tiny pieces to. And of course, it makes sense for a bigger company, but sometimes you can go too far. Like I remember one time we had the platform team create service mesh for developers to use. So you have service discovery, so you can communicate between services using just service name.
Mm-hmm.
Sounds great, and they spent half a year working on it. But first of all, no one asked for it. And we really didn't have no use for it later. It was just looked great on paper, but
I think we even mentioned that. Yeah, but maybe we don't need that because we already are doing it in middlewares.
Like maybe if you have 5 services, maybe you can just call it with the URL of Kubernetes, and wow, it's enough.
Yeah, and all the cross-cutting concerns, you just handle it with common library with with middlewares. That's it. It's probably, again, it depends on context. If you have super complex project with multiple programming languages, maybe. But in this case, we just have one technology there, and it was a solved problem already. So
yeah. So this is all the first part, the technical part we mentioned. Sometimes it's easier than the domain part, the product part.
And it's very often you can move it between projects, as you said earlier. So it's can be very similar across, and you don't need to reinvent the wheel, basically. So we already know that this technical part, it's very often similar between the projects, and the thing that is different is the domain part of the project. And we already mentioned once domain-driven design, that it's supposed to be helping us with this thing that is unique to our company. And many of you maybe heard about this earlier, but it's not widely adopted. Do you have some ideas why it's like that? And actually what maybe domain-driven design is at the first point?
Yeah, maybe it's even difficult to define what the approach really is in very a short description. And I remember before I knew about DDD, my first contact was when my manager wanted to have the entire team join the training of domain-driven design, and they sent me over like a PDF description of it with lots of details what the training is about. And I remember reading through the document, and at the end I was like, what is this? I have no idea how is this supposed to work. Help me with my day-to-day work. Like, I just completely had no idea what's the idea.
So it was more covering some non-technical things, and at this point you were thinking that, okay, it doesn't matter, or it was not sold properly, let's say.
Yeah, I think it was missing the why. And I think, and also DDD has a lot of unique names or terminology that's you didn't hear before. So if someone tells you will learn about bounded contexts, you're like, what? I know about design patterns, but what is this?
Or maybe aggregate, and okay, so I can aggregate some data.
Yeah.
Okay, another reason why it's not that widely adopted, and maybe now it's very often misinterpreted, it's also the reason that domain-driven design is out there already for pretty long time. So the Blue Book, so the book that was introducing domain-driven design, was released almost 25 years ago, and the programming world 25 years ago was totally different.
And it was based on years of experience from Eric Evans. So I guess you can say it was about software written in the 90s. So it sounds like a different era today, kind of. But on the other hand, you can still hear about DDD a lot. Maybe not every company, practices it, but there are conferences and, books dedicated to it. So probably suggest you that there are many good ideas. That's how kind of evolution works. Like, good ideas tend to survive for longer.
Unfortunately, there's also other side that many good ideas are misunderstood with time. So some good ideas are useful at the beginning. More and more people are trying to adopt them. But unfortunately, if those good ideas are not straightforward but require bigger investment to understand them. Some people tend to get shortcuts and not use them as intended or use them everywhere. And it's quickly ending up with some kind of caricature of some techniques, tools. So in other words, many techniques or tools at the beginning were good ideas and were solving some problems. But with time, when people were adopting that, they were starting to adopt some caricature of this technique. And it's often started to do more harm than good. And it was visible in many discussions that we have in many teams that some people have seen domain-driven design in some projects, but it wasn't really domain-driven design what they've seen. They've seen some
over-engineering maybe.
Yeah,
like just doing it for the sake of doing it.
Yeah. So using it in places when it wasn't needed. So it was just too simple application maybe to use that. And to make it worse, it wasn't used in the right way because, well, the initial investment was just too big and people tend to not spend enough time to learn something. And, well, it's easy to imagine that after 25 years, many of projects like that was created. And, well, it created a lot of bad PR.
And you can hear people saying, I don't want to work like this ever again, because it was a disaster. It was a super complex project that was made overcomplicated.
The similar situation is also, for example, with clean architecture, when we sometimes hear that, no, clean architecture doesn't work. And later we hear about 7 layers and...
Yeah, but on the other hand, if you read the introduction to the Blue Book, I think the core ideas are still very relevant. Like the introduction describes the state of most software projects, how they get stuck, what are the issues. And it's almost 25 years later, I think pretty much in the same spot in a sense. We got better with frameworks and some technical stuff, but the core idea of working with people on a product is not that much different.
Are you suggesting that we are reinventing the wheel in software every 10 years?
No, it's not possible.
And it's 25 years since releasing the book, so I can imagine that we reinvented the wheel at least twice since that time. So
we invented microservices and then ditched them
twice.
So it was a full cycle. And for example, in the Eric Evans's book, he says that XML will be a promising technology to communicate between services.
Yeah, it's something fresh to send XML over RPC.
Yeah. So since then we probably reinvented this idea a few times with microservices and protocol buffers over gRPC, or it's basically the same. So coming back to the question why it's difficult to understand what DDD is, it's very broad. It's like entire book of many ideas, and it's from design patterns to communication between teams. So it's very difficult to say what doing DDD means. It's just very broad method of.
We can also say that it's maybe philosophical in some way.
Yeah, and you can interpret the patterns in many ways.
What's good, because the domain part of projects can differ between projects, so it's hard to give one solution that fits all. So it's probably because of that, but it's also creating a lot space to interpret things. It remains one thing. So if you are with us for longer, you maybe already know that some time ago we decided to leave our daily jobs and now we are doing our own business. But it's not the first time when we've been trying to do that. And we've been trying to do it multiple times earlier. But I think one thing that probably didn't allow us to succeed earlier was that we didn't spend enough time to understand actually how to run business, how it actually works, that you're running successful business. So maybe you had some high-level idea that if you would like to have successful business, you need to sell things, do some marketing, do some sales, and earn more than you are spending. Easy. But
you just need to read one business book, which is called Business and explains how to do business.
Yeah, but in practice, it's not that simple and it's more sophisticated, let's say. And if you will not spend enough time to understanding how it works deeper, the chance that your business will fail is much, much higher. I think the statistics are like in 5 years, 50% of businesses are failing. And in terms of startups, it's probably 80% in 2 years or something like that. So it's crazy number actually. And but from the other side, it's something that you can learn, but you need to spend a bit more time to learn those principles and to not do caricature of your business.
So it's similar a bit to the DDD. So it's very, very broad term and like a general approach to something, and you need to learn many patterns.
And it's hard to give one advice that will fit all cases, but it's still doable. But you need to spend some time and keep in mind that many people are not doing this exercise and are later surprised that it doesn't work.
Yeah.
And like with DDD, you can also see that many people are saying that running business is super hard. So I would say that it's hard, but I think it's also not that hard that people think. It's just about knowing the principles and spending enough time on it.
Right. So if you were to boil down DDD to one primary theme, I would say something like it's about understanding the domain you work with and then modeling it well in the code. Whether you call it DDD or not, it's like a mindset more than patterns, maybe.
In other words, you should always do that. I mean, if somebody will tell you that, okay, you should not think about
the domain,
what problems you are solving in your software and how you are writing it in the code. Like, it sounds crazy.
Yeah, it's like you're, deciding, I will create a website. I just don't know which one. So it sounds like you do something for the sake of learning the technology, which is fine, sure. But if you want to create a product, it's not really helpful.
Mm-hmm. My observation is actually that there are two kind of people that are often visible in area of techniques like domain-driven design, architecture, take anything. And there are two camps that are totally opposite. So one camp is saying that, okay, you should always use that because it's great, etc. And the second is you should never use it. It's the worst idea in the world. And I think it's pretty interesting that even if they are opposite, they have many in common because they are extreme in some way. And
so they treat it more like kind of religion rather than something you want to use to deliver a product.
Yeah, and in practice, probably you should be somewhere in the middle. So it may sound obvious, but you should use proper technique for a proper problem. And that's it. And it's important when you see some religious people about techniques or tools that are against of them or love to use it always, that it's the same coin, but just other sides of it.
Yeah.
So I think it gets into one thing that you should watch out to not use any techniques or tools like DDD just for sake of using it. So you should identify the problems that you have and use the right tools for that. And domain-driven design have a couple tools that you can take out of that, like a tool from a toolbox, and just use what you need from that.
There's probably no project that will use every pattern described in the book.
Yes, but probably you agree that every project should use some parts of domain-driven design. So it may sound controversial, but it's getting into a point that you may be using some parts of domain-driven design even without realizing that.
Yeah,
It may be because of reinventing the wheel. Again, it's probably easier to just see that, okay, you have some tools like that, but many of them, some people just can find them.
Yeah, probably except for very trivial projects, but we don't care about them here. Like if you create something that's very trivial and doesn't need any kind of design and architecture, you probably don't need to figure out how to do it better. So we don't worry about this here. Maybe also something very technical like Linux kernel. I don't know. But probably also there should be at least one idea from DDD that applies there.
Maybe value object.
Yeah, but in general, if you boil DDD down to some like very key ideas, I think you should be able to use them if you know what you're looking for.
I think it's a similar situation like with the book Design Patterns. So pretty old one. I don't remember actually how many years.
It's
20,
older
30?
than DDD, so I think 96 or 7.
So still pretty old book, but still pretty relevant. And many of us may be using patterns from this book, even without knowing that those are patterns from this book, because it was used by somebody else, and we learn those patterns by replicating them. But still, we may be missing some of the context maybe of them, and if we'll read that, maybe we could understand them a bit more and apply them in the better situations also.
I remember there was like a joke or people making fun of people in interviews when asked about design patterns, they will tell something like, oh yeah, there's the singleton and that's it. But that's also kind of the point. There's an entire book, and it doesn't mean you need to know all the patterns and use them all in a project. Even if you learn about some, like maybe you can use a strategic here or decorator in another place. I think it's still a good result. You don't need to force them and rewrite your entire project to use, I don't know, like a abstract factory method or something.
It's always about identifying some problem that is really a problem and not solving some imaginary problems.
Yeah, especially if you force the patterns. I think that's the worst thing that can happen, because it just leads to over-engineering. You just read the book and you like the ideas, so you use them everywhere in your next projects, and of course they don't apply to all of them.
And I think it plays nicely with a couple of things that we covered in the previous episode, that we've mentioned that being principal engineer doesn't mean that you're forcing to use some patterns. You should instead be able to convince people what value those patterns give, and those people and convincing them that it's worth using some patterns there. And at the end of the day, it's also a matter of solving real problems, not imaginary problems.
And there's no one solution to suggest, because there are so many factors in play, like the size of your team. So if you are a 20-person team in a corporation, or a sole developer working on open source software, or maybe you are the 5-person startup, you will probably use a very different approach to software.
And also, what's the timeline for the project? Because if you are in a startup that you're starving for, if you don't know if you will survive half year and you're doing refactoring, it's probably not the best idea. But I mean, it depends, obviously. But it's, again, going back to solving real problems that you have. So if you are startup that have half year of runaway and you're fighting for survival, you should choose your fights wisely, basically, and not put maybe refactor some code that you didn't touch for a year and put design patterns there. But maybe you have some part of the application that, for example, you're doing a pivot now, and you need to change it quickly, but you're wasting a ton of time to modify this code. Maybe doing this refactoring and putting those design patterns may be good idea there, even if you're fighting for survival, because maybe it may allow you to build this new functionality or do this pivot within this time that you have left.
should have some idea that this project will be for you longer. You probably need some better maintenance here, but maybe some areas are more, just less important. Maybe you will get rid of them in 2 months if it doesn't work out. But because it's sometimes difficult to decide, this might be a bit controversial, maybe, but I think you don't need to go all in. Most of the patterns from DDD, you could decide to use them in a more, let's say, shallow version rather than deep version. So you basically think of the first principles, the big idea behind the pattern. You don't need to implement all of it and still get some good results. Because you often don't know if the project you work on will be with you for longer, or maybe it's just a prototype. But I think there's a balance between having some very scrappy code and something that's it's very enterprisey, well-designed software.
And it's actually an interesting thing because it's one of the things that domain-driven design covers with core and supporting domains.
Mm-hmm.
So that it's kind of forcing you to think that, okay, is this code really important to my business or it's less important? And it can kind of affect how we are thinking about this code, because I know that many people like consistency in the code. Like, okay, let's do something in the consistent way everywhere. And it may sound like a decent idea, let's say, but it may be also dangerous because you at some point start to over-engineer some parts, because some part of the application are more important, more often touched, more complicated, and some are simpler. You may just lose a lot of time for maintaining this consistency for sake of nothing, basically.
Yeah, so this episode is more like an introduction, but in the next episodes we want to cover more patterns from both shallow and deep end, so you can better decide what to use one.
But I think we should put big emphasis on the thing that people are very often missing. So the strategic part, because tactical patterns, strategic domain-driven design are the patterns that are not that much about how you write the code, but it's more about some strategic thinking, like how the modules are interacting, how modules are splitted.
Very often cross-team collaboration.
How important are multiple parts of the code. And what's interesting, everything what I just said, I think you should probably think about that in any project that you are doing, if you're using domain-driven design or not. It's cool to have some tools that are helping you to do that, and some maybe framework, let's say. It's not framework, the technical framework, but some way of thinking how to approach this.
Yeah.
And from other side,
models.
Yeah. And from other side, you have technical patterns that you're using in the code. And those ones are not always needed, and you don't need to always apply them.
So we won't be diving deep into patterns today, but let's look at the core idea of DDD, the domain model, or model-driven design, or knowledge crunching, how it's specified by the book. What is it about?
So there's one thing in multiple projects that is a bit like running business, like we said earlier. So it's obvious that you should earn more money than you are spending, so you have successful business. And in software, it's a matter of understanding what kind of problem you are solving and how it should work. And it may sound obvious, like, yeah, we are starting a project, we should understand how it works and how we should implement that. From the other side, it's not happening.
Yeah, because sometimes the business is complex by itself. And even for simpler ones, like consider e-commerce, it seems like a simple domain. You just people buy products and that's it. But if you dive deeper, there's capturing payments and delivering the products and getting the inventory somehow. So it's more complex than it seems.
But how it looks in practice, people are thinking, oh, okay, it's simple, we know what to do, let's go to implement that.
Exactly. But
2 years later.
consider, if you wanted to open an online shop, if you ask a software developer, they will probably tell you, you just need to, host this WordPress website with a e-commerce plugin, and you're done.
I think many software developers will say, no, we need to implement it from scratch.
Oh, yeah, that's even better. But my point is, they probably won't think about that you need to order the inventory from somewhere, store it somewhere, and then somehow send it out to people, which is the hard part of the business. And your software probably needs to work with it somehow.
It actually works nicely with this part of strategic patterns of domain-driven design when we are considering what's our core domain and what's creating the value for our company. And
many projects are much, much more complex than e-commerce. Like if you consider accounting, for example, you can get into some very, very specific edge cases depending on the country. And if you do it globally, then it's crazy amount of knowledge you need to understand and to implement. Complexity in those projects doesn't really come from the technical challenges, but from the business itself. It's just complex to run this kind of business. So the software becomes also complex.
So in other words, you have multiple dimensions, the complexity dimensions, let's say, to this product, and you can add more and more and more. So for example, you're starting with one country, great. We need to scale globally. Okay, we need to support multiple countries, multiple continents, great. Yeah. Later, we need to support multiple types of products, so it can have multiple tax rates and multiple rules. It's getting more and more and more complex.
And it's always complex even before you introduce any kind of technical challenges, or just not considering software at all. This is already complicated. So you want to model it well in the code, so at least you don't need to deal with the additional complexity.
And to make it worse, often the initial idea is also changing with the time. So I have two good examples of the companies that were like that. So Netflix. Maybe many of you know that Netflix at the beginning was a streaming platform. At the beginning, they were just renting DVDs. So it's interesting how it changed over time, how they were making business, and probably how much it changed how they're operating. The other thing is the other interesting business that changed over time is Instagram. So Instagram wasn't this kind of social media platform that now. It was more a check-in location application. So I guess you was able to send to people information that, hey, I'm here, or something like that, not share pictures.
Yeah, and so imagine in both cases, like at some point, developers complained that the requirements weren't clear. We didn't know this company would become this thing it is now. Of course, it wasn't clear because no one knew about it back then, and they had to adapt somehow.
Yeah. So those examples were more extreme, let's say, but most companies are changing their initial assumptions pretty much. So it's also adding this complexity there. Yeah. I also like example of the cyberpunk game that the cars are horses from Witcher 3 because they're using the same game engine. So
yeah, so that comes back to the discussion of evolving software. The first version is usually simple, right? Everything works fine, but then someone tells you, actually, we're not renting DVDs, we're going to be streaming videos. And at this point, you have to change your software to a completely different model sometimes. And yeah, it's great if you could do it easily, if you don't need to spend 1 year to rebuild everything. What helps is also what we mentioned in the last episode about developers working directly with domain experts. So
even if it's a bit controversial, so we've seen how it can change things, and again, affect how you are implementing things.
So we don't need a product owner or product manager acting as a proxy?
Always, because sometimes it makes sense, but sometimes it makes sense to just go directly.
But the idea of the domain model is to create a model that represents the problem domain as well as you can at the moment. And the better developers can understand how it works, the more they can information they get from the people who work directly with the business, the better. The model doesn't need to be physical, so it's not a document or diagrams or anything else, although it helps, but it's more abstract. It's about understanding how it should work, and the ultimate artifact is the code, right?
And it also doesn't need to cover everything. So I always like to compare this model part to a map. So map is not a perfect representation of real world, but it's useful representation of the real world. So you can look on the map and see the details that you care about and do the job that you need.
And it's also not a data model, right? Which is a common misconception. Very often in software you can see models used for both the domain logic and some storage, for example, or transport. For developers, this is a natural thing to do. Treat them as the same. So we often start implementation with database schema, for example, because it feels natural to think of storage. But here we think about the more abstract domain model, how the thing works, what behaviors it has.
Yeah, so this is pretty big paradigm shift, and it's also not consistent with how we've been learning earlier. So this is also the theme that was pretty common in last 2 episodes, that how we are learning to code is very far away from the real world, and we are not prepared actually to work in the companies and later it's ending up with the golden cage concept from the previous episode. And yeah, getting out of that is not simple, but I think it's mandatory if you would like to be successful and survive on the tough market and work in the better places.
Another tool from the previous episode is event storming, which is also closely related to figuring out the domain.
So today we are more focusing on giving you some introduction to maybe not domain-driven design really, but some parts of domain-driven design that we've been using in a project. Sometimes we'll name it domain-driven designs, sometimes not, because again, patterns are secondary. I think it's more important to focus on problems, not on the patterns, because when you are focusing on patterns, you are just with this hammer in your hand and looking for nails everywhere. Yeah. So I think it's more important to focus on problems that we are solving and how we can do that. And yeah, this is something that we'll be doing in the next couple episodes. And it's connected to the fact that now we are working on our new training, the domain engineer, and that will be available at the beginning of 200 next year in January.
Yeah, so in the next episodes we will look at more use cases for the strategic patterns.
Yeah, so we'll give you some more practical tools also, how to approach that.
So let us know in the comments if you have any topics you would like to hear about. You can also check our ebook, Go with the Domain, which is about working with domain-driven ideas in Go specifically.
Yeah, so we will be preparing agenda for next episode soon. So yeah, let us know on YouTube comments or Spotify comments. So we'll read all of them, and it will be cool to help you with some projects or problems that you have. We have many stories from projects that we've been working in, but we'd also love to introduce a bit more there.
So that's it for today. Subscribe to our channel so you can see the new episodes as they come, and hit that like button.
And if you don't want to miss when the domain engineer will be available, just Google the domain engineer and join our newsletter if you are not there yet. So we'll send you an info when it will be ready, and you'll be also notified when new episodes will be out, because we know that sometimes notifications from multiple platforms are not sent. So when you're in our newsletter, you are sure that you will always get the notification. Okay, so I think that's all for today. So thank you, Miłosz, for your time.
Thank you, Robert. See you next time.
See you in 2 weeks. Bye-bye.